Hello, I'm Aditya, Vivaldi, Aldila. Me and my group are going, and I'm going to do a demo about our circuit that me and my group have been working for the past few days. So here, let's start. So first, I will turn on this preset and clear first, of course, for the asynchronous input. 1, 1. And this one, 1, 1. So I will try to operate this first before I'm going to explain each of the circuit. So there is an open button here. Power, open switch. Power is for powering. Open button is we hold this button to open for a certain amount of time, and open switch will always open when we switch this on. And this is the door, where if the door is 0, it's closed. If the door is 1, it's open. It's still like this because we haven't run the clock. Okay, maybe I will run the clock with 1 Hertz here, and then it should be 0. Okay, yeah, so it's closed right now. These are the target floor that we want to go to. This is the floor display. This is the target floor that we want. Currently it's F because there is no input on the target floor. This is the current floor, 0. And this is the password. Okay, so if we want to operate this, we make sure the door is closed. This is 0 and this is 0, 2. And we power on. And then we input our password, which is 268. Let's say I want to go to the 5th floor. So we press this. 1, 2, 3, 4, 5. And see this door, it's open. It's open and it's closed after a certain amount of time. So it's like a real elevator. It will open and people go out and close. So let's say I'm going to a lift. So of course I press the open button, right? So we press this, and then the door will say open, and I go in. After a certain amount of time, it will close down. And then I'm in the elevator now. So let's say there is a person who wants to go in. So I press this open switch. It will open, always open the door. Okay, and then after the person is going, after the person has arrived to the lift, we can press this again to make the door closed. So now, let's say I want to go to the 1st floor. So I press this, and I turn this to 0 again. Okay, 4, 3, 2, 1. Okay, and then see here, when the elevator isn't moving, the indicator will be off, both of them. So if I go up, this indicator will turn on, the up indicator, till it's on floor 7. So now if I go down to the 1st floor, it will go down. This indicator will turn on. Okay, I will explain the circuit now. So first we will maybe the easiest part. We'll go begin with the easiest part, which is the password. This is just a decoder. This is 3 decoders. It will see if the input is right. 2680100 to this, 0110 to this, 0001 to this. It will go to this and it will activate the clock enabler. It will activate the lift. Okay, so this is the clock enabler, right? It will determine if the lift will be active or not. And after that, what else? So this is the input. This is from one of the input we will put in an encoder, and then this will go out, and we add this. This is an adder. Okay, we add with negative 1. Why? Because the encoder can only input from 1. So the lowest value that the floor can be is 1. So that's why if I want to put 0 here, I will add negative 1. So I add my 1, 1, 1, 1. I use first and second complement. Minus 1, 1, 1, 1, and it becomes 0. So this will become 0, this will become 1, 2, 3, and so on. After that, it will go to the, this is comparator that focus on equality, and this is the more. So this is the comparator. If this is equal, the left will be disabled. Oh, by the way, this comparator will compare the input and the current flow. Yeah, the current, this is from the input, and this is from the current flow that we get from here. This is the current flow. Okay. By the way, so now this is the comparator also. It focuses on A less than B. So what does this do? This will determine if the leaf will go up or down. It will done automatically. We don't have to toggle manually if the leaf will go up or go down. So this will do that. How does it do that? It will compare the same like this. Compare the input or target floor and the current floor like this. Okay, and then oh yeah, this one. So this we use this is the decoder. Yeah, this is the 4 input decoder. It will go in here. So what does this do? Why is there a decoder here? So what does this do is, if the floor is going up, this will go on, and if the floor is going down, this will turn on. but if the leaf isn't moving, which we know from here, okay, from the comparator before it I've explained, it will disable the this coder. So because of that, this won't be turned on. Okay, so what does this do? Okay, because if our target is F, this indicator will still be turned on. So that's why I made if that our target is F, which is 1111, it will also disable this decoder. Okay, so that's how I make this what do you call it? Indicator will only be turned on when the leaf is moving. Okay, now this we use shift register. So for this open button, okay, if we use open button here without the shift register, it will, when we press the button and we release the button, it will immediately close down. But we want, when we push the button and we'll release, there's a certain amount of time that the door will still open for like 1 or 3 or 4 or 5 seconds. So that's why we use shift register here. We use piezo here. So here we use piezo because actually I can't find seesaw in here, so that's why we use piezo, and I think it does an equal work. So when a value go here, it will go to the piezo, and then we immediately go also. We break the flow here. So one flow straight go to the door, and one flow go here. So when we release the door, there is a certain amount of time. When we release, it will still be activated because there is still a value from this piezo, from this, because 4, because we want it to be longer. If we want it to be even longer, we can use another piezo here. So that's why. And I think, yeah, so this is the last. So this one, okay, it uses the similar concept from this. but I want I want this. Okay, so if we see this input is going from this one, equality comparator. So this equality comparator will give the signal to this, okay, which, let's say, if the lift is not moving, the door will always be open. I don't want that. What I want is when the lift is stopped, it will open for a certain amount of time, then it closes. So how I done this? Okay, so we detect if the lift stops, it will generate a pulse, okay, which we break this into two in this part. One straight go to a T flip-flop. This is T flip-flop, okay, JK, and then go to, this is one input. So this is T flip-flop. And this input act as a clock. So when this input go to 1, this immediately toggle, okay. Before this is 0, 0. So when this is toggling, it will immediately toggle. This become true, and then we toggle the door, okay, and then the door will be open. But there is still a pulse from here that is not yet go to here. So let's say a certain amount of time, so it will be open, and then after, let's say, 3 seconds, this pulse will go here, 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 and then it toggle after 3 seconds. So that's how I make the door to be open for a certain amount of time, and then it close. Okay, so I think that's the demo that I can do. Okay, let's do it once again we'll do it right now. So let's see, 1 2 3 4 7. We'll go 1 2 3 4 5 6 7, and I want to go to 0 now. 6 5 4 3 2 1 0. We'll open, and then it will close now. Okay, so that's it. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.